Hi, my name is Brian Wong, and today we'll be looking at the effects of fatigue on surface electromyography amplitude. Hand grip strength is usually measured with a hand grip dynamometer, and it is a predictor of overall muscle strength and functional capacity. Muscle fatigue is defined as the inability to maintain the required or expected force or power output. One way to measure muscular fatigue is through surface electromyography, which allows for non-invasive examination by means of surface electrodes placed on the muscle bellies. A symptom of muscle fatigue during an isometric contraction is an increase in EMG amplitude signal, which is interpreted as the recruitment of additional motor units. The purpose of this study was to investigate the effects of muscular fatigue on EMG amplitude, and it was hypothesized that as muscles begin to fatigue during a sustained isometric contraction, EMG amplitude will increase. The subjects recruited for the study were all recruited from the Regis University DPT class of 2021, and 8 subjects were recruited. Their mean age was 24.5 years old, and standard deviation was 3.34. Inclusion and exclusion criteria are listed below. Subjects were seated in an armless, backless chair, and electrodes were placed on the muscle bellies of the wrist flexors and extensors of their dominant hand. Subjects performed a maximum grip test in standard position with a hand grip dynamometer, and a maximum voluntary contraction was recorded. 25% of a maximum voluntary contraction was calculated, and the subject was asked to maintain that 25% in an isometric contraction for as long as possible. Subject was cued every time force exceeded or fell below 25% maximum voluntary contraction. Peak EMG of wrist flexors and extensors were recorded every 15 seconds along with force until subject could no longer maintain that 25%. Values were then converted into a percent standard, and means and standard deviations were graphed over time for standard EMG amplitude for wrist flexors, wrist extensors, and standard force. Mean values for EMG amplitude were graphed over time and displayed on the first 2 graphs, with the green line corresponding to wrist flexors and the blue line corresponding to wrist extensors. The third graph represents the standard force graphed over time and maintained. The standard values for wrist flexors and extensors increased slightly over time but overall remain fairly constant. The standard force remains constant over time as expected. After 195 seconds, the data recording for certain subjects stopped due to the inability of the subject to maintain 25% maximum voluntary contraction. So our hypothesis was not supported due to the standard EMG amplitude not noticeably increasing over time as suggested by previous literature. Muscle force did begin to decrease more notably toward the end of the test, which confirms previous literature, but did not result in a noticeable difference in EMG amplitude. Data variability could have been caused by errors in methods of collection and equipment errors. EMG equipment calibration, electrode placement, and stopping the collection of data when patients were no longer able to sustain the contraction all could have contributed to the large variability in the data. In regards to the clinical relevance of this test, the understanding of effects of fatigue and its mechanisms will aid in the prescription of exercise for muscular endurance and patient education. Thank you so much for your time.